All right, good morning, everyone. So we had our, well, two quizzes last class. I do want to talk about the largest one because the exam, although it's not going to be the same questions, but they're going to be similar in a way of me asking you things that, a lot of these things we've been doing a lot. Some of them, you had to either do through an assignment or something that you were exposed to that, we didn't repeat that specific thing over and over, but at least it was something that was important in that context. So I want to show you first some stats of the grades, and then we're going to dive into each one of the questions and, discuss about what was the right answer, what were some other answers I got, and why those were not the correct ones. So overall, this is the mean distribution for the entire class. So here I think is ranging from 40 to 100. We had a lot of people being between 90 and 100 for this quiz number 4. Just remember, this is, again, just a quiz, right? So even though we had many questions, it's still going to be weighed into the quiz category. So it's not a midterm, but I wanted to give you a feeling of the things I'm checking if you're learning them or if you're just copying code, which if you're just copying code, I think that happens. But at the same time, I want to ask you to think more about what we're doing. And I'm trying to do that as well as we develop coding class. So when I ask you what should go here, what function should we use? What's the proper way of doing this? So that is my attempt to make you think about what you're doing and not just simply copy code. So a summary of the total grade. So the mean was 90, the median was 98. I think we got a couple hundreds, and then the lowest was 44. This is the distribution of grades within a given question. So we see that a lot of people got really high marks on most of the questions. Sometimes if it was, this is something I really want to stress out here because it is a detail that I'm sure you don't want to lose points because of that. So a lot of questions, it's like a two-part question. I ask you, what is something and why, right? So if you give me just the first part of it, I can only grade you for 50% of that question. I cannot grade you for the second part of the why if you did not provide me an explanation, right? So this applies to the quiz and will certainly apply to the exam. Make sure you read the questions, make sure that you understand how many parts I'm asking you on that specific question, that you answer all of them, so you qualify for getting all the points of the question. So here there's some questions that, like, if people got 50% was probably because they either answer the two parts of a question, so what is something and why? So maybe they answered just the what it is, but did not tell me why, or maybe they did answer both parts, but they got one of them wrong. So that's something I saw for a couple of questions and for a few students. But overall, I guess everyone was getting high answers here, or high grades for the different questions that we had. We had total 9 questions. And I do want to, so today I want to take the time for us to go through the quiz answers, what I was expecting, what were some of the answers we got that may not have been the correct ones, and talk about them. And really, I want to open up for any questions you may have, especially as we prepare for the midterm. So I want this to be a class that we just talk about those types of things. All right, so this first question here, if it was geospatial or not. The answer I was looking for was that it was not geospatial because the file we're bringing in is a CSV file. So remember, there is this distinction between the file and the object. So the file was a CSV file that in itself is not a geospatial file. It does have columns that we can transform this object into geospatial, but the file itself is not geospatial. What I did here is, because this is perhaps a little bit confusing and I don't mean to be tricky, I'm really just trying to see what you're thinking. I did consider, if you said that it was geospatial and you gave me an explanation of why you thought that was. So if you said this is a geospatial file, which was not the correct answer, but if you explain because it has like X and Y axes or X and Y columns, I still accepted that as the correct answer. So really, it's not a geospatial file, but if you said it was and you explain that, you got 100% points on this question.
So on the, I guess I was using that kind of thought it was geospatial because it was points
Mhm,
that had data related to the like geographic points.
mhm.
I think that's what I said, but I don't know, that's kind of what I thought geospatial meant.
Yeah, and I think it's more of a, so Doug is saying here that he thought it was geospatial because he had the columns. And that I saw, you were not the only one that interpreted that way. But if you did say that, you got 100 points, right? So I did not discount points. I think it's more of the meaning of what the question is, because the question I think was like, is this file geospatial? And anyways, I think it's just like more of an interpretation form. And that's why I was lenient on the grading. So if you said it was not geospatial because it is CSV, you got 100%. If you said it is geospatial because it has coordinates, you also got 100%. All right, so there were, again, some functions here that we're talking about as far as being like some of the ones we're using a lot, probably in every script that we do, right? So what is the function that we use to transform a data frame in this case? So the file is CSV. When we import into R, that becomes a data frame. So the object is a data frame. Now we want to transform that data frame object to a geospatial object, right? What is the function that we do for that we need for that? We use this a lot. So that would be the STSSF, right? So this is a very common function we've been using. And then here, I was not expecting for you to tell me like that we have to say chords equal X or Y. But if you recall, this function here requires you to say there's an argument called chords that you say, what is the column that has the X? What is the column that has the Y? So some of you said set as SF. If you set, it's really close, it's not the exact function, but I also consider this, I think if you gave me a set as SF, you got a 90% on this answer. So you did not get full points, but I saw that you were like thinking in the right direction. You knew what was the function. You could just not remember exactly what was the function. So I still got most of the points for that question if you gave me another answer that was not ST as SF. And then I think everyone got this right. Yeah, so everyone got number 3 right. So once we do the STSSF, this becomes a vector of type point object in R, right? So it would become a point, and I think everyone got this right. So it would not become a raster, I guess, right? It would become a vector. So here, I think most people got this right. And I just want to make one point here to explain. So I think maybe a couple people said that the gridded soil samples was a raster, and I just want to take a moment to talk about that. Even though we did not analyze gridded soil sampling data in this course, but I wanted to show you an example for the field that we've been working with of how that would look like if we actually had collected this type of data and planned for this. Really, this is just us planning, me making a map of us planning for taking those types of samples. So field boundary vector, everyone got that right. It is a polygon, so it is vector. Gridded soil samples, this is what we would be thinking about. So when we do gridded soil sampling, we first create a grid, right? So here I have a grid of, I don't know what's the cell size here, maybe it's 100 by 100 or something like that. And then we have these points within each one of the grid cells. In this case here, so normally what you would see is people would create a grid. They would extract the centroid of each one of these cells, and these cells here would be polygons. So we get the centroid of the polygons and they sit right in the middle. What I did here was just to add a little bit of randomness to the location of the point within the cell, just so we create different distances for kriging. We did not talk about that in class either, so I'm really not, this is not what I was expecting you to tell. I'm just saying what we're looking at here and how I got to it. But anyways, if we think of, you have a grid that is a vector, and then you get the centroid of that grid, and even if you make changes on the location of the point or not, it's still a point, right? So we will go to this field, we will go to that point location, take, let's say, 10 soil samples around each one of those points, put all that together in a bucket, get a subsample, send for a lab. So gridded soil samples would be, there is a grid and the location of the soil sampling is a point. So that would be vector as well. I think most of you got this right, but I just wanted to show you how that will look like in practice. UV imagery, raster, I think everyone got this right. County boundaries, vector of type polygon, smartphone picture, raster, satellite imagery, raster. So I think these last four, everyone got correctly. And on this question specifically, we had 1, 2, 3, 4, 5, 6 answers. I just did like how many answers you got right, divided that by 6 and multiply by 100 for how many points you got in this question. So question 4, if we look here, I think most people got 100%, a couple people got 80% or 83%, which is if you miss one of those classifications, and then we have one that was 0 for some reason. Okay, so I do want to stop here and ask, especially related to raster or vector, if anyone has any questions, if this is too confusing for anyone, for us to talk about it. So if you recall, we did this a little bit, which was when we had a raster object and we transformed that to vector. So you can always go back and forth between these two file types, right? You can always transform a vector into raster and a raster into vector. But natively, you would expect for them to be one or the other, depending on the layer we're talking about. So it could be a little bit confusing. And just another point that we've made in this class is, if you remember, the main difference that we can tell between vector or raster is, in our case, when we're doing the interpolation, that happens as a raster. And then we are transforming that raster into a vector to make it easy for us to visualize and to work with the data. When we plot both of them, they look very similar because the raster cells become mini polygons when we transform to vector. So they look very similar, but one difference that exists is, if you remember, rasters need to be a continuous layer that is determined by the bounding box. What is the bounding box? It's basically the westmost, northmost, eastmost, and southmost coordinates of your field. So imagine a rectangle that is touching on all of those limits. That is the bounding box of this layer. A vector, like we're seeing here, can have empty spaces, right? So we're not seeing anything out here between the boundary and the bounding box, the imaginary bounding box, I guess, if we were to think about that. A raster, on the other hand, is continuous layer. It has cells everywhere. Even if you don't have data in a given cell, so, I mean, this is not a raster, so we would not really, I guess, look at this and think of a raster. But if this was a raster, if this were a raster, we would have cells all the way until the bounding box. And even if you had no data, those cells would be coded as NA, but you still have cells there. So this is another way of thinking of the difference between raster and vector. Okay, so the next question was, if you, based on the data set that you were given, which I guess I'm not showing here, but I just printed the first 5 rows, and I asked you, based on that data set, which were the columns you needed to apply the filters. If you gave me at least these two, speed and dry yield, you got it right. I think most people got this right. Some people gave me speed, dry yield, point X and point Y columns. You got that right as well. We did not get extra points for it, but that still makes sense, so I did accept that. You only got this wrong if you gave me another column that was not one of these, right? So again, the question was, which one of these columns do you need if you want to perform the min-max speed, min-max yield filters? In class, we use the speed and the dry yield columns. And in this case here, these were the names of those columns in that data set. So this is what I was looking for. Okay, so question 6 was about WGS 84. I was asking you if you remember the EPSG of it and what was the unit, right? So most of you did remember the EPSG. We've been seeing this number a lot. So 4326 is the EPSG for WGS 84. I'm asking you this not because I'm like, well, let's test their memory, which I guess in part is what I'm doing, but I'm doing that because this EPSG is the most common that you're going to run into in whenever you work with spatial data. So I'm kind of asking you to see if you remember this, because again, it is the most important one for you to remember. Of course, you can always Google it if you don't know, but you know, it's a good one to have on memory as well if you work with spatial data a lot. And remember, we had a talk about geographic or projected CRSs. WGS is a geographic CRS, which means that its units are in degrees, and these are angular degrees, right? So it's not like Fahrenheit or Celsius or that type of degree. It's a degree in the sense of angular degrees. So this one here on the, so then the next question, question 7, I was asking you between WGS 84 and UTM 8083, which one did we need to use when we're doing distance-based operations? Like, for example, calculating a buffer or maybe doing interpolation. So just a refresher here, WGS 84 is geographic and is in degrees. UTM 8083, the one we've been using, is in meters, right? And it is projected. So because it is projected, it is in meters. And every time that we are doing something that's based on distance, we want it to be in meters. Sometimes, for some occasions, very specific cases, that may not matter, but sometimes it does. So by default, I think it's a good to have a default of saying, let's always keep this in meters if we're going to be doing something that involves distance operations. I wanted to show you that here, even though this was not part of the question itself, but I do want to show you why that mattered and how. So I'm bringing here our boundary from our the boundary that I digitized on my side. I'm bringing that and I'm calling this boundary WGS 84. And I'm printing that here so we can look at it. So it is a polygon. It has one feature, so it's just one polygon. It is the boundary for our field. Here it says that geodetic CRS is WGS 84, and then it gives me a geometry here. So we're all used to this output already. It's just that when we print this on an HTML format, it gives me so it gives me the X-min, X-max, and so on, based on the WGS 84 units, and then also gives me here some information about the points that make this polygon. Okay. All right. All good there. So then on the next chunk here, I transform this boundary WGS 84 to UTM NAD83 by using the function stTransform. I am assigning that to an object called boundary UTM, and I print it just so we can look at it. One feature, polygon, just like before. Now my X-min, Y-min, X-max, and Y-max of the bounding box are different because now it is in meters and not in degrees anymore. And then these values here are also different from before. Here it says polygon in degrees, here it says polygon in meters. So really up until here, nothing new. We've done these steps a lot where we bring a layer, we assign, or if it comes already with a CRS, we don't have to set the CRS. But if it does not have a CRS, we have to set it. In this case here, I do not have to set because I already came with WGS 84. I'm just transforming it to UTM on this step here and then printing. So just for you to remember, boundary WGS 84 is the one in WGS 84. Boundary UTM is that one transformed to UTM. All right, so the next step here is I want to buffer both of these objects, and I want to show you what happens, what's the difference, and why degrees is not a good idea. So I'm coming here, starting with my boundary WGS 84, I'm creating a negative buffer of 20. So this function stBuffer takes this argument called dist. This number here is going to be whatever unit your CRS is in. So if my boundary WGS84 is in degrees, minus 20 means minus 20 degrees. So if I do that and I print buffer WGS, look what happened. I do not have a bounding box anymore. It's all NA, and my geometry is empty. I do not have data in this geometry. That's because if you do a negative buffer of 20 degrees, and this was my boundary, right? So if I do a negative buffer at 20 degrees here, it just collapses in itself because 20 degrees is a lot more distance than what this field represents. So basically I'm going inwards and kind of like you don't have anymore where to go because it's so many, you're buffering so much because you're doing that based on degrees. So you end up without a geometry at all. When I do this again, ST buffer, that dist argument is based on whatever units that CRS is. If the CRS is geographic, is doing minus 20 degrees, which is way more than what our field represents. Then we end up with basically no geometry at all, and because of that, no bounding box as well. Now, if I do the same thing, but with the UTM one, so I start with the boundary in UTM and I do the buffer of minus 20 as well. So the same function for the buffer, the same distance, but now this distance here is in meters because it's using the units that the CRS that is starting off has. Because boundary UTM is in meters, this minus 20 is minus 20 meters, which does work, is not collapsing in itself. And then we end up with an actual geometry here that has the coordinates. We have a bounding box as well. So again, if we are doing distance-based operations, we should not use CRSs that are in degrees because that distance may affect, or the fact that your CRS is not in an actual distance measure like meter or feet, but in degrees, that could affect your results. This may not happen, perhaps, if you're doing other operations. I believe if you do this with interpolation, I think behind the scenes, it accommodates that. You kind of transform that to a meter-based CRS, does it for you, and then gives you back, and then retransforms back to WGS84 and gives you back the results. So some functions accommodate that, others don't. Like ST buffer does not accommodate for that. So again, because of this, because some functions do accommodate and others don't, I recommend that every time you're doing distance-based operations, make sure your object coming in is in a projected CRS that could be in meters or feet or any other planar distance measure. So the answer I was looking for here specifically was that you told me that you needed UTM and NB83 for distance-based operations. And I think we mentioned in class what this was, but I did not show you this clear example here for you to create this understanding. So I'm just doing that now. So I hope that, with this example here, it becomes more clear why we need to have the meters when we're doing distance-based operations. Any questions here? All right. So the next one here was actually pretty simple. I'm bringing the data set so it could make a plot. I did not ask you to give me this code here, right? All I asked you to do was give me the code to make this map, which if you gave me something along these lines, you got 100%. I think most of you did do that. I am bringing here just so I can make an actual plot and show you. So this was the code I was expecting, right? So if you start with ggplot, again, so the question said, I don't know if you recall, but the question was, if you have a spatial SF object with this column, how would you plot it? So some of you gave me the code, a different code that would still work potentially, but it was not exactly addressing my question. The answer I was asking here is, if I'm telling you on the question that I'm giving you an SF object, which I did tell you in the question, then this is an SF object where you need geom_sf to plot it, right? If you told me that you use geom_sf and you had your AES color equals this variable that I gave you in the question as well, then you got 100%. What some people did was they used geom_point instead. So geom_point would work if the object was not SF. If you remember this CSV file that we bring in, that is not an SF object yet, it's just a data frame. On that CSV file, we do have the columns for the coordinates, right? So point X, point Y are columns in that data set. If you're plotting that data frame, which is not an SF object, then you could use geom_point and you have to say inside AES, you would say X equals point X, which is the name of the column, Y equals point Y, and then color equals EOPOM per acre. That would work, that approach would work, but not with an SF object, just with a data frame that has the columns point X and point Y. So if you gave me the answer of geom_point and you made sure that you had your X and Y specified on the AES, in case you were assuming this was just a data frame and not an SF object, I still gave you 90% on this question. You did not lose all the points. You just got a little less points because I told you in the question that this was an SF object, so you should have used geom_sf. Do you have a question?
All right, so I had yield before it with a pipe so that it would bring the data in already. Like yield and then pipe it to ggplot plus then that goes into geom_sf with the size and everything. So would that still work?
Oh yeah.
Or would it?
Yeah. So and I think if I remember well, I think you were the only one that did that, but that would be the same. Yeah. So Doug is saying like if he gave me, so here I'm specifying the data set here. He was asking if he did not include this part here, but he started with yield, pipe, and then getting to the plots. Yeah, that is equivalent. So I consider that to be the same. Yeah. Any questions here about this in specific?
So, process during the exam, like if we don't get the exact code, but we're almost on that line, is it okay?
Yeah, so I'm not a hard grader. I'm not gonna be it's all or nothing, right? So if I see that you're in the right direction, because like so you're gonna here, for example, on this question here, I think I did not give you the name of the data frame. So whatever people said that the data frame name was, I accepted that, right? I kind of assume that if you don't know the name of the data frame because I'm not giving you, as long as you assume something that makes sense, that is a good assumption. So I did not grade in this case based on how you name your data frame. I did, however, I was expecting that you'd set color equals EOPOM per acre because I did tell you that was the column name. So if I tell you something and then you kind of ignore that, then you lose points for that. But it's not going to be like an all or nothing. I'm always going to consider, were you in the right path? Were you thinking in the right direction? And then give the student some points for that. So this was one example that this was or some variant of this based on, like you could have a different data object name here, but if you gave me some version of this, you got 100%. If you went the route of geom_point, I can tell we were going the right direction, but maybe you did not see that I mentioned that this was an SF object, so you lost 10 points out of 100 on this question, right? So you got 90 points on this question here. All right, and then lastly, I think most everyone got this part right, which is just I just wanted to see if you had already developed this intuition of how like you would set up your projects. And I did this because in a previous semester we got to this point and I still found people were confused. And again, my goal with the quizzes is to give me an opportunity to see if there are gaps between what I'm saying and what you're understanding. And if there are gaps, then I want to address those, right? So this was just a question to see if you were understanding that flow of how we're moving things here. All right, so I do want to tell you that I plan to invest a good amount of my weekend on your attendance and your grades for everything you've done until now. I will have that this weekend, so you can look at your grades, you can see what, I'm gonna provide you feedback whenever you miss points, so you're gonna know why you miss points. And if that doesn't make sense, you can still reach out to me before the exam. We can talk about it. I can explain to you. Or even if you think that you answered correctly and I gave you, a grade that doesn't represent your answer, come talk to me. We can always touch base. I may make mistakes. So I'm always open for us to talk, especially if that is gonna help you to understand what you did wrong, and then you can learn from that and learn, what happened and not make that mistake again. So yeah, so this weekend I'm gonna do that. Just a reminder for everyone. So we do have quizzes, assignments, the mini project. Those are all different categories of things that have the different weights. If you want to know more, you can go on the syllabus and check on that. We also have the attendance policy. I just want to remind you again. I know, I would expect that if you have to miss a class or if you miss a class, that you know the policy that we talked about on the first day, which basically is if you know we're gonna miss a class, you have to miss a class, let me know beforehand. I will dismiss you from that class. You're not gonna get a missed class, right? However, if you don't let me know and you simply miss class, you can do that 5 times. If you do more than 5 times, I have the right of dropping you from the class, because this class, even though I provide the videos afterwards for you to study and catch up if you need to, but I still expect you to be here to attend the class live, right? So just keep an eye on that as well. And after this weekend, when I post your attendance and your grades, you're gonna have a tally of, both your overall grade, but also your overall attendance, and keep an eye on that. Okay, so this was what I had to talk about the quiz. The exam is gonna have more questions. Some of them are gonna be a little bit more complex. I do tell you that, always make sure you triple read the question statement, because sometimes I've seen a lot of students miss points, not because they did not know, but because they forgot to answer something that was part of the question, or maybe, they got confused, or something that if they just reread that again and made sure that they were addressing all the points, they would have gotten a higher grade. So that's something I want to tell you. It's going to be written, so you do not need a computer. You're not going to be allowed to use your computer. It's going to just bring, if you want, pencil or a pen, whatever you want to write on paper with. You're going to have the 2 full hours on Wednesday, so we're going to have that blocked for you to take advantage. Last semester, some students finished in like 40 minutes. Some students took the whole 2 hours. So you do have a maximum of 2 hours. You're welcome to use that if you need to. It's a closed book, so you're not going to have access to anything other than what you can keep in your brains. And of course, it's individual. So, you are expected to not cheat. And if you do cheat, I reserve the right to give you a 0 or drop you from the class. So that's very serious. I just want to make that clear that it is an individual exam. What else? I guess as far as studying content, as you can see here, I'm gonna ask you some similar things, and I hope that you could tell that I'm asking you things we're doing a lot. Of course, for the exam, you would have time to prepare, you have time to study, which you did not have for the quiz. So it is understandable if you miss something in the quiz that maybe you would not miss if you had time to prepare. So take the quiz as a framework of the types of questions we're going to have. I'm going to ask you things about the assignments. So go back to the assignments. If it was a reading assignment, make sure that you specifically look into the questions you answered. Those are going to be things that I may ask in a different way than I did. It's not going to have exactly the same questions as assignments, but it could be related. So make sure you check your assignments, check your code again. I do want you to understand what we're doing at each step. And if it's something we did once, I'm not going to ask about that. My goal is not to be tricky, is not to be picky. I want you to know what we're doing, the overall goal, the direction we're going, the main functions we're using, that we're repeating every single script. Those are things I can ask you, just like we've been doing in class, right? So if we're writing code and I stop and I say, what function should we use here? Those types of questions are related to that, are things I can ask. We're gonna have some theoretical questions as far as what we talked about in the assignments. We're gonna have some coding questions that I'm gonna ask you fill in the blank, or maybe I'm gonna give you a plot and I want you to fill in a pre-started code with some blanks, and I want you to look at the plot, look at the code, and see what you should fill in the blanks with to represent and get the plot. Again, things that we've done a lot, and nothing that is going to be like, we've never seen this before. So some theoretical questions about precision ag, as far as relates to the assignments, go through the scripts, make sure you check the functions, especially functions we use a lot, make sure you understand what they're doing, when you should use, for example, something that we did a lot in this class, you're going to do a lot in your career if you keep using geospatial data is, if a data frame comes in without a CRS, like a CSV would, how do you set the CRS? How do you change the CRS? How do you transform a data frame to an SF object? Things that we've been doing a lot and that are important for you to understand the steps and the differences. If you go back to the codes, you're going to find a lot of that. Yeah, I think overall that those are the tips I wanted to give you. Any questions? Mm-hmm.
You want to mention the difference about SF and SP
Mm-hmm. Yeah, so Diva is asking the difference between SF and SP. So in R, those would be the main two package types to handle vector data, vector geospatial data, SF and SP. SP was the first one that was developed. And even though a lot of other packages that were related to geospatial data were relying on SP objects, that is falling out of use. So SF came to kind of replace SP. And so even though you may still find, some packages, some tutorials that are using SP, but I think people are shifting more and more towards SF. And that's mostly because SP, so when it was invented, it was the best thing we had in R at least, but it has a lot of like different types of objects and different classes, and it's more confusing, and it's not easy to plot an SP object. It's not easy to use an SP object with tidyverse. So it's not pipeable, doesn't really work well with ggplot. And because ggplot, dplyr, all these packages became so popular in the R community, a lot of people want things that work with them. So SP has that downside as well, not working well with those packages. So it's also falling out of touch because of that. Yeah. Any other questions? All right, so just again, a quick reminder, we're gonna have a class next Monday. We're gonna start talking about soil EC. That is not gonna be in your exam. The exam is gonna go up until what we saw on the last time that we did an exercise, which was the terrain, right? So the terrain, the exam goes until the terrain exercise. And we are not going to include the soil EC on the exam, but we're going to start talking about that on Monday. And then Wednesday is the exam, is the same time of the class period. So 9:10 to 11:10, you're going to have 2 hours to complete it. It has to be in person in your campus location. So those in Tifton, it's going to be at the room you're in right now. Kumar, I wanna, if later you can
Yeah.
just send me an email with what is the room that you go to for your
Okay.
location, so I can make sure that someone is there to proctor it for you.
Okay.
And so, yeah, it is gonna be in your on campus location. Wednesday, 2 hours to complete, no coding or no computer. It's just gonna be on paper, even though I will ask you both theoretical and coding questions related to that in the exam. All right, any other final questions? Okay, I don't hear anything. So, Clint, I will follow up with Skylar for you to make up the exam on Thursday. If anyone else cannot do the exam on Wednesday, let me know. I can accommodate that. But if you can, and I expect that most of you could, then it's gonna be during our class time on Wednesday. All right, if no more questions, then we can wrap up for today, and I'll see you on Monday. We'll talk about soil electroconductivity then. Thanks, everyone.